Hi, everybody. We're really excited to be here in this room. I've learned a lot today. I'm Meredith Miller. This is Chris Humphrey. We're two of the three leads of Post-Rock, which is an initiative to transform waste plastic into building materials. So I'm here in my role today as a wannabe entrepreneur, but I wear many hats. I'm a licensed architect with a small practice. I'm an academic, so I teach students and I do research. I'm also a mom of two kids, ages 4 and 7, who both love nature. They love collecting bugs, they love identifying birds, and they love picking up rocks. Coincidentally, there's a new rock you might have heard about. I learned about it several years ago that inspired our research. It's called plastaglomerate, and it's formed as waste plastics in oceans and beaches, combined with natural materials like sand, coral, or other minerals. So these are very alarming signs of the damage that is being caused by plastic pollution. So the mom in me wonders, what are the rocks going to be that my kids are picking up as they grow older? But then the designer in me thinks these are actually kind of beautiful and intriguing. They're varied and unique in how they look. So the researcher sought to understand these composites by recreating them in our fabrication lab. And then the budding entrepreneur in me saw an opportunity. So Post-Rock came to be to create a new end-of-life use for problematic waste streams by producing durable building materials. So we're in the process, still kind of early, in commercializing our research with the goal of selling exterior cladding products with greater amounts of recycled content than any existing product. In Michigan, as you know, is a perfect place to develop our technology with a concentration of manufacturing happening here, but particularly the automotive industry, which generates 309,000 tons of plastic waste every year, and some of this is very high quality plastic. So we plan to use that waste as feedstock to create value for the building industry, so kind of crossing those two sectors.
Buildings are being built very differently now than they were 20 years ago due to new energy codes and a growing concern for operational and embodied carbon. As the construction market shifts towards building enclosures with higher thermal performance, rain screen facade systems are expected to dominate the market with an annual growth rate of 7%. We see a great potential to claim a portion of the custom composites sector of this market. After completing over 150 customer discovery interviews, we learned that there's a demand for rain screen facade panels, especially those that are low in embodied carbon and offer custom aesthetics. Our product, the Post-Rock rain screen panel, turns plastic waste into a unique architectural cladding that will fill the market gap and provides architects, builders, and building owners with a low-carbon, highly customizable alternative. By using undesirable plastic waste as a feedstock, we hypothesize that we can competitively price our product and retain a high profit margin. Through our patented thermocasting technology, we are able to efficiently mold custom panels using industrial robotic arms with a small heating chamber attached to the end, ultimately resulting in less heat loss and lower energy usage as compared to the large ovens used in traditional rotational molding techniques. Irregularities in recycled content, such as granule size, are a problem for standard manufacturing, but not in our process. It's actually a benefit. We have the ability to take advantage of various sizes of waste combined with robotic movement to replicate aesthetic effects that people love about natural stone, such as stone veining and marbling. As architects and fabricators, we're used to thinking big and imagining new possibilities, but now we're working to build a business that will have real impact. There are still several hurdles, and yes, as you're already wondering, plastic does burn. But we're starting to test plastic waste from automotive applications that are already fire rated, so we can achieve fire certification with minimal additives.
So right now, we're building out the expertise that we need, and we're gaining momentum with some research funding to get us to some key benchmarks. So a full-scale mock-up is being planned for the summer, which we're going to build in our fab lab, small-scale flammability test, and soon a proof of concept that passes, hopefully, the most critical fire safety test for exterior wall assemblies. So looking beyond this research plan, we know we need to consider scaling up, moving out of our fabrication lab to self-manufacture or license our technology to an existing manufacturing partner. And then we also want to grab our customers' attention, so we want to do a high visibility demonstration project. So as I think about the world that my kids will live in as they grow up and become ecologists or geologists, or if you currently ask my daughter, a pop star, I wonder if we can redirect yesterday's waste to construct tomorrow's buildings. Thank you.